Buongiorno a tutti, buongiorno, sono Matteo Dallago, Product Manager di Digimax e vi do il benvenuto a questo nuovo webinar sulla tecnologia LensVector. Abbiamo deciso di organizzare questo secondo webinar, in realtà, sulla tecnologia LensVector, proprio per condividere il più possibile quello che sono le caratteristiche di questa tecnologia. In particolar modo su questo webinar lo abbiamo focalizzato su quelle che sono poi le applicazioni di questa tecnologia. Qualche settimana fa abbiamo fatto un webinar più focalizzato magari sull'integrazione della tecnologia LensVector nei corpi illuminanti. Questo webinar di oggi invece sarà più incentrato verso un audience di progettisti e light designer, proprio per condividere la tecnologia non solo con chi va a realizzare le lampade, ma per condividerla anche con chi poi andrà a utilizzare questa tecnologia e potrà sfruttare le caratteristiche e le potenzialità della tecnologia LensVector sui propri progetti e sulle proprie installazioni. Per fare questo abbiamo coinvolto David Kribel, che è il responsabile commerciale di LensVector, che è qui con noi e che terrà questo webinar in inglese. Giusto per darvi qualche informazione su come verrà tenuto, appunto David farà un po' tutta la sua presentazione sulla tecnologia in inglese. Ci sarà una sezione question and answer che trovate disponibile a schermo, dove potete andare a scrivere le vostre domande. Siete in molti collegati, per cui non possiamo fisicamente darvi l'accesso per interagire direttamente. Potete interagire nella chat e ci sono i nostri colleghi che potranno rispondervi o direttamente online, oppure alla fine del webinar dedicheremo circa 10-15 minuti a raccogliere un po' le domande più significative, le porremo direttamente a David e quindi potremo darvi le risposte direttamente. Se non riusciamo a rispondere a tutte le domande, vi invito comunque a contattarci tramite i recapiti che troverete in chat, oppure il vostro commerciale di riferimento se già siete in contatto con noi. Non vado avanti oltre, lascerei la parola a David, che è qui con noi, che si presenterà e ci intratterrà su questo webinar.
Ciao, buongiorno. Thank you, Matteo. I'm very happy to be here with you this afternoon. It's best to do this in English because I have a very, very small Italiano. But today we're going to talk about the LensVector technology and products and how they allow for a digital connection in smart lighting applications. And as we think about that, you know, your job as a designer when you create a space is to choose the correct equipment that allows you to put the light where you want to put the light, to create drama, to create interest, to highlight certain pieces, artwork, sculpture, in a retail application, to make sure that the owner of the shop can sell many watches. And the idea to do that is you need light in certain places, and to be skillful at that, to be good at that, you have to be able to manipulate the light. So as a lighting designer, as a store designer, as a museum designer, you pick lighting equipment to allow you to put light where you want it. And as we move into a solid state world where we use LED, we were able to very easily control the color of the light and the intensity or the brightness of the light digitally with a DALI or with a DMX. And the thing that has been missing so far is the ability to change the shape of the light digitally. So to be able to manage it in the same way that we manage RGB+W, or in the same way that we manage color temperature tuning from warm white to cool white, and to be able to manage it the same way we manage dimming. But now with solid state technology for lenses, we have the ability to manipulate the size and shape of a beam of light. Until today, the way we do this is we use many lenses, or we use mirrors, or if it gets really crazy and busy, we use a motor. And if you think back to theatrical lighting, we use what we call a zoom fixture, or a fixture that can go from 10 to 30, and we move lenses in and out to be able to change a beam. And these light fittings are very expensive, and they're often very large, and they're difficult to use maybe in a museum or in a retail shop, or in the type of building that is a more commercial everyday or a more residential everyday type of space. And all that begins to change now with the technology that we have in terms of digitally controlling light. And so what we do at LensVector is we bring the opportunity for you to be able to use light fixtures, light fittings that allow you to make the light move without having any mechanical movement. So we're working at the molecular, the really, really small level of the lens, and we control that electronically. And now the same light fitting could do something like this, where you start really narrow and you have many different sizes of spot on the wall, but every one of these light fittings at the top are exactly the same. And the way that we change the beam is by manipulating the lens inside the light fitting. And so we'll talk a little bit in two ways. We'll talk a little bit first about the technology. How do we do this? It's not magic. And then we talk a little bit about the electronics and how this gets integrated into the luminaire or into the light fitting, and also then what you can expect and how this needs to work for you on the projects that you work on, designing light fixtures, designing spaces, things like that. So really, this becomes very simple. So we say simple dynamic digital, but it's a very simple process. We use the LensVector lens, the luminaire light fitting you want. We use the phone with some sort of digital signal, and then we have the ability to change the light. So inside the lens, this uses liquid crystal technology. So when you think of liquid crystal technology, you can think of things like an old calculator where the numbers change, or the fuel or petrol pump where the numbers move. A lot of that is liquid crystal technology in being able to have a liquid crystal display. The difference is LCD display, like LCD TV, uses many, many layers and also uses a lot of polarization in the screen, and it becomes very expensive. With liquid crystals, we use this is not display, this is just liquid crystals. So we use the self-aligned molecules here, and by being able to manipulate how the molecule moves, we can change how light, when it goes through the lens, bends. And that's the process. So it's a very simple process in terms of being able to bend light by manipulating a crystal. When we put this into optics or into a lens, in a very simple way, when the lens is static, the light goes straight through. When we put light through and we manipulate the crystals, we can bend the light, either causing the light to focus, or we can do it in a way where we cause the light to shift or to bend. And by taking these three different crystal positions or orientations, we can then create lenses that are larger, that use many, many crystals, that give us the opportunity to be able to do things to a beam of light. And so what happens in the basic LensVector lens is the light comes in. We have many, 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 many micro lenses, or a little array. And right after the lens, we make a focal point. And so by pushing the light past the focal point, we cross over, and then we can spread the beam like this. So it allows the beam of light to open up, just as you saw in the graphic a couple of slides ago. So we can start with something very simple like a spotlight, and then as we move, we can take the spotlight and create larger beams. And this, as you know, would be very applicable for many of the projects and applications where you're putting projectors and you have a spotlight, and maybe the projector ends up on the project being a little bit farther away than you originally specified, because that's just the way the building was constructed. And now you have this small beam of light on a bigger object, and with today's electronic capability to digitally control, we can open the beam up a bit to illuminate the entire object. It's very similar to the way we dim a light to make sure we have the right amount of illumination, or the way we control color to make sure we get the right color on a surface. But it can work in this way, where we start with a very narrow spot and we can end up with a much nicer, bigger beam. So really, how does the control work? It's the lens, it's the luminaire, and then it's the Casambi app. And the Casambi on the phone or on the tablet, in conjunction with the light fitting in the lens, is what allows you as the designer or the owner of the restaurant or cafe or gallery space or retail shop to be able to manipulate and control the light. We also have the ability to use DALI DMX. In North America, we use 0 to 10, but really, the true freedom here is to use something like a Casambi, because of the ability that it gives you to be very free from wires when you control the fixture. So here we talk a little bit about how this makes the lighting system different from the other luminaires that you buy today. And really, the only difference is adding the LensVector lens. So in most projectors, you already have some sort of optic, reflector, collimator. You obviously have LED holder, some heat sink, some driver. But the thing that needs to add is the LensVector. And that's the simple part. And to be able to talk to the LensVector, we use a control board. And so as I move to the control board now here, I will let Matteo talk a little bit just about the control board and about Talknet, the lighting company, the lighting control company that builds the control boards and how they go into the luminaire. So we have a small little technical conversation here about how we do this. So Matteo, over to you.
Yeah, thanks David. In questo webinar non andremo nel dettaglio, nello specifico, sulla parte tecnica dei sistemi di controllo per la tecnologia LensVector. Volevo solo darvi due concetti. Ovviamente, come diceva David, per realizzare un proiettore con il fascio controllabile del LensVector è molto semplice dal punto di vista meccanico, basta aggiungere appunto il LensVector di fronte alla sorgente luminosa. Ovviamente però c'è bisogno dell'intelligenza che va a controllare il LensVector. Per fare questo Talknet ha sviluppato questa scheda che vedete a schermo, che è una piccola schedina che può essere integrata sulla maggior parte dei proiettori in commercio, che permette di ricevere una tensione a 48 volt ad esempio, andare a controllare il LED e controllare anche il LensVector. Tutto questo viene fatto tramite l'interfaccia Bluetooth Casambi. L'interfaccia Bluetooth Casambi è la tecnologia che noi abbiamo ritenuto la migliore in assoluto, come la più avanzata, la più scalabile, la più flessibile, per permettere proprio questo tipo di controllo dell'illuminazione veramente molto evoluto. E, ne approfitto anche in questo momento anche ad annunciarvi che la prossima settimana, giovedì, sempre a quest'ora, faremo anche un webinar proprio rivolto alla tecnologia Casambi, al suo funzionamento e al modo in cui possiamo andare a utilizzare questa tecnologia Bluetooth Mesh avanzata per il controllo dei progetti di illuminazione. Ovviamente la tecnologia Casambi è per noi quella più versatile, però la facilità con cui si va a condizionare questi cristalli liquidi del LensVector ci permette poi di andare a lavorare con qualunque tipo di controllo elettronico, che possa essere un controllo di tipo DALI, che possa essere un controllo di tipo analogico, che possa essere un controllo di tipo DMX, quindi lì dipende un po' sempre dal progetto, dal tipo di richieste del cliente, però diciamo che la tecnologia si presta ad essere applicata con diversi tipi di interfacce. Ok, David, if you want to go further.
Okay, thank you, Matteo. And so now we talk a little bit more about how things work and the types of effects that you can get. And so you see here in this little video that we have some light fittings, and they're just shining down, grazing down this wall. But the light can move very quickly. And the ability to change the light in the different distributions here, you could obviously stop anywhere in the middle, but the lights moving can move very fast. They could be programmed to create attention or in a space, or they can be just programmed or adjusted to be able to demonstrate and get the light to focus in certain areas. So again, really the system is meant to be either dynamic and moving for certain applications, or also the type of system that you could adjust or change either in an initial aim and focus type of scenario, or also in a type of scenario where you wanted to create different scenes for different types of different times of day. So, you know, why again do we think about controlling shape of light? And it's because we've always been controlling the shape of light. As designers, you know that you need to put a certain amount of light in a certain place to have the statues in the gallery, or to have the retail look correct and stand out and pop in certain applications. And that's why we need to do this. And so when we start to think about different applications, this is a project that it was completed in North America in Boston, in one of the sports stadium retail shops. And there were 250 projectors in the retail shop with LensVector lenses, so that they can highlight different jerseys, or when they move the racks around, they can put the light more tightly on the rack or more wide on the rack, or change the shape of the spots on the floor. Now, the cool thing about this project is because it's in a sporting arena, when the team that's playing scores a goal or a basket, the retail shop plays a little show. And so all the lights are connected through a wireless and then a DMX system to what's going on in the arena. And when they score a goal, the person who scores a goal, their jersey gets a big circle around it of light, and all the other lights turn off, and they make it be a big deal so that the fans from the stadium go to the shop and then they buy more merchandise. So it's a very interesting experiential retail application, and therefore complete control over the luminaire and the lighting effect is desired. Now this is an application that is exactly opposite and the other way. This is an application where there's very few places to mount luminaires. You see light fittings are hiding behind columns or up on top of columns and ledges. And we want to try and create effect on frescoes, on statues, on sculptures that may or may not move around in a museum. And by putting lights all the way up here and having them project down, if we can change the shape of the beam when we move or change the exhibit or change the size, we can be 100% certain that the sculpture, object, painting is illuminated, has the right amount of light, has the right shape of light to create the effect we're looking for. And then even at the same time, we may choose to have a different type of lighting in a museum or a retail or a restaurant during the day or at night. And again, the shape of light, as much as the color and the intensity of light, can help to create different scenes and different moods in different spaces. So how do we do all this? Well, when it comes to what we provide from LensVector, we have really two different types of products, and these would then be built into the light fitting or the projector by the luminaire supplier. So one allows you to go from a very, very super narrow beam, say 5 degrees, to about 50 degrees as a very wide flood. And then another one works more in the middle and is from 15 to 35 degrees. This is really where the majority of the applications are for things like retail, gallery, restaurant, hotel. The very narrow to very wide is a little bit more like museum or very, very specific retail. But the flexibility is important to be able to have that from a range. As you know, you sometimes specify a very narrow spot, or sometimes you just need a regular spot. And so it's okay. And then with the lens and the different sizes, we have different sizes for different size projectors. So 35 millimeter may be more like 500 to 1,000 lumens, and 65 millimeter may be more like 3,000 lumens. But again, different sizes for different amounts of light. Now, a new thing that is just being introduced now is that the ability to use this technology in an exterior outdoor product. So this is an in-ground product. You can imagine being able to put something in the ground. You never have to open the seal, and you can still change the light. Is very cool on outdoor buildings because you maintain the integrity of the environmental protection. So water, dust, things, but you can still change the beam. And so for us at LensVector, the big challenge with this was to be able to make the lens withstand the sunlight, because liquid crystal and sunlight, sometimes they don't make such nice friends. And we were able to work on a way to be able to block the UV light so that projectors like this can be outside. And then you can end up with application like this, where when you shine the light on the building, you can make the beam work very well to illuminate the building exactly as you wish. Also, you could program a show for a special day. This is a little bit like maybe earlier this week in France for Bastille Day, but this building's in the UK. But you could change the way the beam is and the shape of the beam on the building for special events, or just to be able to make sure you cover the building the way that you would like to ensure a very good quality lighting result. So now you will start to see light fittings meant for exterior application to also be able to have very, very good beam control electronically with the app, with the Kasambi. So again, you know, we come back to, this is simple. It can be dynamic. It can be adjustable, but it's digital. And this is the part that matters. We control the shape of the light the same way we control the intensity and the color of the light today. And now we have all things covered. Now, this is a little bit of what I call the sneak peek. So we always get questions. If you can move light any way you want to move light, how come you only move light in a circle? And moving light in a circle is first, and it's sort of the most obvious, easy way, that we use light and for us to manipulate light. However, the interesting thing is as we move with the technology, we will be able to stretch the light in multiple directions. So we can stretch this way or we can stretch this way. And what that will allow us to do is to be able to take something that may start or look like a circle and stretch it into a shape that is maybe a little bit more friendly for architecture. So maybe we can stretch into something that's more like a square or a rectangle. It will not be like a framing projector with a really hard edge. It will be a more soft and a little bit more elegant situation. Now, the other thing that we work on is how do we steer light and move light, and can we add things like a dark window or dark places? And those things we can work on in the laboratory. We write research papers about those things, but that's a long way from becoming a commercial reality. We're working very hard to be able to stretch light like this and still have good architectural beam quality. And that's hard enough right now. But really, you know, in our lab, we prove that we can start with the beam and end up with something more like a square that still looks very good and has a very, very nice nice beam quality. And that is important in architecture, in gallery lighting, in retail lighting, in hospitality lighting. The quality of the light is important to make the space feel correct. A few practical things. How does it work in terms of optical transmission, how much light goes through? And this really depends on how far we spread the beam. The farther we spread the beam, the more light we lose, because more light is absorbed and scattered in the little liquid crystals. The power consumption is not very much. We can move the beam very, very far, as you see. So sometimes almost up to 6 times the original beam. And the lens itself is not very thick. It's just a couple of millimeters. And where is this being used now? And how is beam shaping working? Well, as we were saying, there is much beam shaping going on in an old way, maybe with multiple zoom fixtures or standing on a ladder and changing lenses. But what we're starting to see is that beam shaping is starting to be in places like in companies from like Togetti and Forma Lighting and RCL, where they've introduced smart fixtures and they've included beam shaping, and it becomes fully digital and electronic. And this is what's exciting, because these are the light fittings and the products that you have at your hands on your palette to make your space be what you want it to be and to do it in a dynamic way. And if the companies, the light fitting manufacturers that you like to work with are not listed here, this is why it's so important to understand the technology behind, because you can talk to them or they can work with Digimax to be able to easily add that last lens to be able to make the light fixture smart and be able to work in the way you would like it to be able to work. And so really the things that are possible is from the really narrow spot to the wide flood and everything in the middle. And remember, it's, you know, no moving parts, and it works really, really anywhere, or really, like we like to say, everywhere. So Matteo, I will say thank you, and I'll ask, I'll push it back to you in case people have questions or there's any questions on the chat, and we can do English, Italian, Italian, English, however you need to do it.
Okay, thank you very much, David, for the very, very interesting presentation. There are actually a few questions on the chat, so I will send you back this question. Ci sono un paio, qualche domanda anche abbastanza interessante sulla chat, per cui adesso porrò le domande in inglese a David e poi eventualmente le tradurremo così in modo che possa essere comprensibile a tutti. Allora, una prima domanda, anzi forse sono due domande che forse voglio più o meno chiedere la stessa cosa, riguarda come influisce il LensVector sulla qualità del fascio ottico, quindi proprio sulla qualità dello spot, e come influisce poi sul color over angle. So, David, the two questions are related to how the LensVector affects the quality of the beam in terms of spot shape and the quality of the spot, and also about the color over angle of the light that goes out from the LensVector.
Okay, thank you. Two very, very good questions, and both extremely important. The first question about the quality of the beam. So interestingly, when light leaves a reflector or a collimator, it tends to be traveling in this path. And what we do with light when it comes out of a very collimated beam before the lens is it's super straight. And then after the lens, if you recall from the slides, we cross the beam over and we make that focus, and then we spread the light. And so by crossing the beam and spreading the light, the lens eliminates and reduces a lot of artifacts that you see from collimators and reflectors, because the artifacts of the collimators and reflectors are seen on a wall because they come straight from the optic. And in this case, because the light focuses and crosses, it sort of makes it a little bit like having a diffuser, and it makes those a little bit softer. So Matteo, maybe I'll let you explain that, and then I'll come back to the next one.
Ok, thanks David. La risposta di David è praticamente una caratteristica...
Matteo, yeah, now you go.
Ok, una delle caratteristiche del LensVector è proprio quella di andare praticamente a curvare i fasci luminosi che arrivano molto collimati, perché abbiamo un'ottica stretta di partenza. Questi fasci vengono praticamente incrociati tra di loro per ottenere l'effetto appunto di apertura del fascio, e questo permette di ottenere uno spot leggermente più smooth, quindi più morbido. Quindi eventualmente, soprattutto quando si lavora con fasci molto stretti, in cui la qualità dello spot in sé potrebbe non essere ottimale, proprio perché l'ottica molto stretta non è facile da ottenere con un fascio molto pulito, il LensVector di per sé va, diciamo, a pulire un po' delle imperfezioni del fascio. Quindi possiamo dire che va addirittura a migliorare la qualità della luce in uscita. Ok, un'altra interessante domanda che si collega abbastanza a questa è l'applicazione di una tecnologia come quella del LensVector su sorgenti luminose, tunable white o RGB. David, another question that probably is maybe a little bit connected to the previous one is the use of LensVector with a tunable white and RGB or RGB white light sources.
Okay, so we'll talk about the tunable white and the RGB and also color over angle all at the same time, because all three of these ideas are related. So if you use the LensVector with an RGB, RGB+W, or tunable white, it works very well and can help a little bit with the mixing of the color. So traditionally or typically when a luminaire manufacturer designs the optics for an RGB, RGB+W, or tunable white, they make sure that the optic that comes after the LED has some mixing capability in the lens. Say in the LEDL lens, it will have some mixing capability so we don't see little dots on the wall. The LensVector lens, again, because we cross the light, helps to diffuse and to mix together the color. So that's an important one. Now, when we talk about color over angle, we talk a little bit about physics. So the challenge with any light is when you put white light or through a prism and bend the light, the different colors of the rainbow all bend a little bit different. Blue bends a little bit more than red. And when you refract the light or redirect it, it can cause the color of the light to change. Now, this is very dependent on the light source that's selected and the collimating optic or reflector that you're using. So in most systems that employ LensVector, if the collimating optic and the light source are well chosen, you can sometimes get just a small bit of color shift or color over angle. So maybe 1 macadam. And it's just important to understand in your application how this may affect things. And it can be a little bit different with each of the different beam shapes. The nice thing is, if you're using, say, a color tunable source, a white tunable source, you also have the opportunity through the electronics to be able to ensure that you would have same exact color temperature with different angles, because we know and can predict how the light source behaves. So Matteo, that's a lot, and it's a lot in English and a lot technical. So I pass it back to you to make that very simple in Italian.
Thank you, David. Ok, la risposta, allora, su quello che riguarda l'utilizzo... Ok,
now you go.
Here. Per quel che riguarda l'utilizzo della tecnologia LensVector con sorgenti luminose tunable white o RGB, il concetto di base ritorna un po' su quello della domanda di prima, cioè il fatto che LensVector è in grado di piegare questi fasci e andare a incrociarli in questo meccanismo di apertura del fascio, permette di andare a fare quello che si chiama il color mixing. Normalmente quando si fanno dei proiettori a fascio stretto soprattutto con tecnologie tunable white o RGB, è necessario che l'ottica abbia o una lavorazione superficiale o che vengano usati dei diffusori interni sopra, davanti o dietro l'ottica, che vanno proprio a fare l'effetto di color mixing. Altrimenti, quando io vado a proiettare con un'ottica molto stretta una sorgente luminosa che non è un unico punto con un unico colore, mi troverò i diversi colori, tunable white con 2 diversi tipi di bianco, RGB con i diversi tipi di colori, mi troverò questi colori distribuiti in modo un po' non del tutto uniforme sul target. Grazie al LensVector questo effetto di color mixing si ha direttamente dentro il LensVector, perché proprio questo effetto di andare a mescolare un po' i raggi mi fa appunto un effetto di uniformare il colore o il bianco della mia sorgente luminosa. Per quel che riguarda invece il discorso del color over angle, cioè quindi come va a variare a seconda dell'angolo di uscita la luce, ovviamente qui si va abbastanza sul tecnico, ma comunque è una cosa comunque molto importante per garantire che il fascio luminoso in uscita del LensVector abbia comunque una sua uniformità di caratteristica cromatica. I diversi colori, quindi diverse lunghezze d'onda, quindi diversi colori, vengono riflessi in modo leggermente diverso quando passano attraverso il LensVector. Ovviamente questo effetto, c'è un leggero effetto di shifting, proprio perché ad esempio il blu non viene deviato, diciamo, allo stesso modo ad esempio del bianco, del rosso oppure del verde. Diciamo che però se la sorgente luminosa di partenza e se l'ottica di partenza sono scelti in modo adeguato, si tratta comunque di variazioni all'interno dello spot in uscita che sono all'interno di uno step macadam, quindi diciamo che sono variazioni che difficilmente, molto difficilmente vengono percepite dall'occhio umano. Ovviamente questo poi dipende un po' dal tipo di applicazione, dal tipo di sorgente luminosa che si va a scegliere, però lì insomma è un lavoro che ovviamente va fatto per cercare di massimizzare la qualità della luce in uscita. Ovviamente un'altra cosa molto interessante che diceva David, collegando al discorso del tunable white, se io ho la possibilità di utilizzare una sorgente tunable white, l'elettronica con cui io vado a controllare il LensVector mi può permettere anche di compensare eventuali color shifting. Quindi io posso, tramite l'intelligenza che ho a bordo dell'elettronica, andare a compensare quello che è il color shift dovuto al LensVector e quindi andare sostanzialmente a impostare il colore oppure la temperatura colore di bianco precisa tramite appunto questa interazione tra LensVector e il controllo del tunable white. Ok, un'ultima domanda, anche questa abbastanza interessante, da capire, si chiede quali possono essere i limiti a livello di flusso e di temperatura. Questo magari si va abbastanza sul tecnico, però è importante capirlo anche per sapere un po' quali possono essere magari eventualmente dei limiti in termini di dimensioni, ad esempio, del proiettore, o in termini di poi applicazione finale. So David, one last question is related to which is the maximum flux or the maximum power that we can use with the LensVector, and also this related which is the maximum temperature that it can work.
Okay. Okay, perfecto. So the two about maximum temperature and maximum flux are very much related. And really, the amount of flux depends on how the heat and the temperature of the light fitting is managed or is designed. So the lens can take 75 C on the glass, and to manage that, we just have to make sure that we have a very good thermal design of the optics. So we have companies that have designed products that have 5,000 lumens and have kept the lens below 75 C. So I think it all depends on whether the light fitting is going in the ground or in the air, and what type of climate or environment it's in. But it's 75 C, and we have seen designs of beyond 5,000 lumens. So to you, Matteo.
Okay. Ok, thanks David. La risposta è abbastanza semplice. Non ci sono in realtà limiti al flusso che io posso usare con LensVector. In realtà il limite è dato dalla temperatura di funzionamento. Ovviamente più alto è il flusso luminoso, più mi troverò una temperatura elevata sul LensVector. Il limite fisico, diciamo, per cui il LensVector viene considerato affidabile è di 75 gradi sul LensVector. Ovviamente è una temperatura molto alta se consideriamo che siamo distanti in realtà dalla parte che emette calore, perché comunque tra il LensVector e il LED che emette il calore molto probabilmente avrà un'ottica, avrà comunque una certa distanza e anche del materiale. In ogni caso il limite è dato proprio dalla temperatura, quindi questo dipende un po' dal design termico della lampada e dal tipo di installazione, quindi se è sotto il sole oppure se è in ambiente caldo, cose di questo tipo. Quindi il limite in realtà sul flusso non c'è. David citava anche di aziende che sono arrivate a fare proiettori con 5.000 lumen con il LensVector, mantenendo appunto questi limiti di temperatura, per cui è tutto legato alla questione termica. Concluderei con un'ultima veloce domanda legata all'affidabilità del prodotto. Mi chiedono qual è il numero massimo di cicli che può sostenere questa tecnologia. So David, one last quick question is related to the reliability of the LensVector technology. So they ask how many cycles, open and close, the LensVector can support in its lifetime.
Okay, good question. The LensVector lens, in terms of cycles, the number is basically infinite. It can be many. The lens does not get tired. And when you think about the lifetime and the amount of change that we have in lighting, the number of changes we have in lighting is so small compared to the number of changes in an LCD screen, a TV, or in even a display where numbers are constantly moving. So the number of switches changes is unlimited. I mean, we see going many, like 10, 20 years. It's you can constantly be changing, and it's okay. For you, Matteo, sorry.
Yeah. Thanks, David. Penso che sia quasi superflua la traduzione. In ogni caso la risposta è: il numero di cicli è infinito. La tecnologia è quella che abbiamo su tutti i televisori, su tutti gli schermi che abbiamo tutti i giorni, e quindi il numero di cicli è praticamente infinito, proprio perché è una tecnologia comunque matura e che conosciamo molto bene. Insomma, i cristalli liquidi non si stancano, ecco, questo è il concetto. Siamo arrivati un po' oltre il tempo limite, per cui chiuderei brevemente. Vi ringrazio nuovamente, ringrazio David. Thank you very much, David, for your interesting presentation. Mi dicono che ci sono altre 2 domande, un attimo solo. Ok, un'altra domanda che mi è arrivata, risponderei direttamente io, se David è d'accordo. Mi chiedono se è possibile mettere il LensVector senza usare un'ottica, una lente. In realtà la risposta è no, nel senso che è necessario, siccome il lavoro del LensVector è quello di aprire il fascio ottico, io ho bisogno che questo fascio sia collimato, quindi io ho bisogno che il fascio sia stretto di partenza, quindi io ho bisogno di un'ottica che mi faccia il fascio stretto. Ovviamente se sono in grado di fare un fascio stretto senza usare l'ottica, la cosa si può fare, però in linea di massima per fare un fascio stretto ho bisogno di un'ottica, preferibilmente una lente TIR, ma potrebbe essere usata anche un riflettore, l'importante è che il fascio sia collimato, in modo che il LensVector possa fare il suo lavoro di andare ad aprire il fascio luminoso. Quindi il LensVector lavora aprendo il fascio, non stringendo, quindi ho bisogno di un'ottica proprio perché altrimenti no. Sarebbe una luce diffusa e quindi il LensVector andrebbe a diffonderla ancora ulteriormente, quindi non si avrebbe un effetto di beam shaping. Ok, detto questo, direi che è il momento di ringraziarvi tutti, siete stati molti a partecipare, quindi è segno che questo tipo di eventi riscuote un certo interesse, la tecnologia è interessantissima, è veramente forse una delle cose più innovative che ci sono attualmente nel mondo del lighting, per cui ringrazio David, thank you very much David, vi ringrazio tutti voi, vi annuncio già che vi verrà recapitato per mail un questionario, per cui ci teniamo insomma ad avere il vostro parere anche su come è andato questo webinar, perché per migliorarci, visto che abbiamo in programma di farne molti ancora, quindi abbiamo bisogno anche del vostro feedback. Detto questo, io vi ringrazio, vi do appuntamento la settimana prossima, sempre qui, stessa ora, 4:30, giovedì, ci sarà un webinar sulla tecnologia Casambi, quindi sulla tecnologia di controllo Bluetooth della luce per applicazioni anche lì di qualsiasi genere dal punto di vista dei progetti luminotecnici. Grazie a tutti.